Hello everyone, I am your presenter for mathematics. So yeah, for this coming week, we're going to be focusing on functions as you've already seen up here. And yeah, all the other details of our program will be communicated on WhatsApp in our groups. But yeah, we are definitely starting this week. So yeah, let's get into business. Now with functions, I usually start with hyperbola, so that's what we're gonna do even today. We're just gonna do a quick summary on a hyperbola, then start doing questions on a hyperbola. And as time goes, we'll start introducing new things, new terms that we might not touch right now, uh, which you'll definitely see, especially the analysis part. But yeah, let's just start. So our focus is a hyperbola. Now a hyperbola is in the form y is equal to a over x minus p plus q. Sometimes you find that here it's just written plus p, but sure, that's fine. We'll get to that and I'll try to explain what is actually happening down there. But yeah, so that's just it. This is how hyperbola is written. Now, in terms of what is what is the outlook of a hyperbola? The outlook of a hyperbola always will depend on one thing. In this case, it will depend on the value of a. It will depend on whether a is positive or a is negative. Now, what happens when a is positive? I'm just gonna draw two lines. So these lines represents my asymptotes in this case. A hyperbola always has two asymptotes, right? So my dotted lines, which are representing my asymptotes. These are my asymptotes. There we go. Yeah. So if a is positive, you'll find that your hyperbola or your function will be on these two opposing quadrants. I don't know. For me, I picture it as if these asymptotes are creating a new system of axes in a way. So if you've got these two lines, which are separate, which are asymptotes, definitely for me this becomes quadrant number one and number three. So that means if you have a being positive in your hypothetical quadrants, which are created by your asymptotes, you'd say it's quadrant one and three, right? So the opposite happens when a is negative. It will be just something like this: quadrant two and four, where in terms of your asymptotes. But yeah, that is just the general outlook. You'd expect your graph to behave like this when a is positive and like that when e is negative. Let's just quickly talk about Q and P. I'll start with Q. Q just represents one thing: vertical translations from the x-axis. So I'll just say vertical shifts. It represents vertical shifts. That means when the graph is shifting up or down, you'll expect Q to be affected. Now, if you come check down here, we've got P. Now, this represents the horizontal translations from the y-axis. That means your graph is moving away or towards the y-axis. So that's definitely a horizontal shift. Either to the left or to the right. We'll do much of this when we start doing questions, but that's just it. Next up, let's quickly talk about sorry, let's quickly talk about one more thing. What if now y is given in the form of a over x, just like that? So this is quite simple. That means your p is 0 and your q is 0. And this will tell you one thing you'll see just now when we talk about asymptotes. It will tell you that your asymptotes are literally on the y-axis and the x-axis. So your graph on the y-axis will either be like this or be like that on your y and x-axis. So just the general Cartesian plane. So yeah, now let's talk about asymptotes because I've been saying the word asymptote throughout. So asymptote is just where the graph is not defined. In layman's terms, we just say our graph doesn't touch that line, but it approaches. So in this case, we've got two of them. We've got a vertical asymptote and a horizontal asymptote. How do you see a vertical asymptote? So a vertical asymptote is and will always be given by where the graph is undefined. So this is going to be a point where x minus p is equal to 0. Remember that the form for our graph here is y is equal to a over x minus p plus q. So where always a graph is undefined, which is just down here, that is going to give us our vertical asymptote. So x is just equal to p. That also means if you had a over x plus p, if you wanted your vertical asymptote, it was just going to be x plus p equals 0, where x is equal to minus p. So do look out for that. Signs do matter here. But yeah, that's just it in terms of the vertical asymptote. Now moving to the next asymptote, we're going to take the horizontal asymptote. Now this one is just simple, right? It's just y is equal to the value of q. So just q. Just like that, whatever q is, that becomes your horizontal asymptote. Now, one thing I'm going to caution you about is not that vertical, it's x. Horizontal is y. Don't make that mistake of swapping or of swapping the two. That's just perfect. Also, speaking of asymptotes, let's add up another thing where our graphs have some axis of symmetry. So what is the axis of symmetry when with a negative gradient, with a positive gradient? That is just simple. Every single time, if you are asked to find the axis of symmetry with a positive gradient, just go for this. Y is equal to minus x plus c. So this is what I always do. Just use y minus x plus c. So these are just axes of symmetry. This of symmetry. So this with a negative gradient. So negative m. That's just it. With a positive gradient, this is going to be y is equal to x plus c. Now the big question here is, how do you find c, right? It's actually very simple to find c. You just look for your axis. You just look for your asymptotes. So it's going to be p is to q. Here, substitute here and find c. Substitute there and find c. So if you're asked for the axis of symmetry with a positive gradient, you just go for this. Then look for your asymptotes. Make them a coordinate. Substitute. Here you're going to substitute your your horizontal asymptote, which is given by y is equal to q. Here you're going to substitute your x asymptote, which is your vertical asymptote, given by x equal p. We can quickly just substitute here and try do something and see if it works out right. So for our y, we can just put in what? We're putting in q, right? And for x, we're putting in p plus c. So that means c is just equal to p minus q, right? This is equal to, c is just equal to p minus q for one with a positive gradient. We can rewrite this formulas definitely by just saying y is equal to minus x plus c. Oh, sorry. Am I doing it correctly? Oh, well, sure. So this was derived from this, right? So that means we can do it for this, for that one. So y is equal to x plus p minus q, right? So that's just it. Y is equal to x plus p minus q. So you find what p minus q is, and put it there for a positive gradient. That is very important. What about a negative gradient? You can actually do the same thing. Find c first, find what c is, and then write it in that way. I'll just give you that as your own task. Go find what y would be in terms of p and q. Well, it's important for you to actually know how to do this type of manipulations, making c the substitute of the formula in terms of other variables. You know that is very important for just your math basically for its entirety. You might be asked to write down something in terms of other variables, so do get to practice stuff like that. But that is just what I was trying to show here. Well, your core thing here is if you want your asymptote with a positive gradient, just y is equal to x plus c. Use p, q to find c. Done. With a negative gradient, minus x plus c. Again, use your pq to find c. Done. That's just it. Now let's move to talking about how do we find the domain and how do we find the range. Now, this is definitely very simple, right? If you want your domain, so your domain, domain is in terms of x values. So x is just an element of real numbers. But there's one thing that x is not equal to. X is never equal to p, which is your asymptote. That's just it. So you just take your asymptote as it is, your vertical asymptote as it is. But the only thing that you do here is you just show that it's not equal to. If you want your range, you'll do the same thing. Y is an element of all the reals, but take down your asymptote again. Y won't be equal to q. That's just it. You've managed to find your domain and range for this part. Now, that's just it in terms of a parabola. I can't think of any other thing that I might have missed. Just that, okay, I asked you to do something up there, right? I can try show you something quickly. If you want the axis of symmetry, you could just use y is equal to plus or minus x plus p plus q. That's just a summarized way. With a positive gradient, it's just y is equal to x plus p plus q. Negative gradient, y is equal to minus x plus p plus q. That's just it. This is the manipulation that I was asking you to do up there. But sure, in general, just use y is equal to x plus c for positive, y is equal to minus x plus c if you won't be able to cram this, which I think you should. But yeah, that's just it in terms of our first lesson. Hope you guys got to understand this. If you've got any question, just text any of your tutors and ask about this. You'll get your response. Sure.